Thanks for joining today this Grafana Labs webinar and co-presented with ClickHouse. And as the slide says, we are recording this webinar, and please feel free to submit any questions you have using the Q&A feature or the chat. We will take some time at the end of the webinar to answer this. My name is Riyad. I am the integrations product manager at ClickHouse, and today we assembled a team of presenters for you to discuss the Grafana and ClickHouse stack. Basically, my job is to make sure that we have a good ecosystem of integrations. There's no point running a database if you cannot talk to it or integrate with it, and that's basically my mission statement. Today we have Andrew from Grafana.
Hey, yeah, I'm Andrew. I build and maintain plugins at Grafana.
And Dale from ClickHouse.
Hi, I'm Dale. I'm part of the product marketing team at ClickHouse. I also contribute to various things, including the Go client and Grafana, but I'm mainly responsible for technical content at ClickHouse.
All right, thanks. And as you saw in the title, it's all about ClickHouse and Grafana, but since this webinar is hosted for Grafana, we thought it would be a good idea to introduce what is ClickHouse, just in case you don't have a good idea of what it is. But also, we want to get a good understanding of the audience today. So we will run our first poll that will help us understand basically who knows Grafana, who knows ClickHouse, and who knows both in the attendees. Please answer on that poll, and we can always check the results once you submit your answer. All right, so what is ClickHouse? ClickHouse is, first of all, an open source project. It's a vastly popular open source project that started in 2009, that was open sourced in 2016, and that is widely adopted for what we refer to as real-time analytics use case. We have more than 1,000 contributors. We release every month on something, a new version of ClickHouse. By the way, the release webinar was yesterday for January, and it is a column-oriented data store optimized to answer aggregation queries. So if you have lots of data and you have tough questions to ask about this data, ClickHouse is your friend, and it achieves its magic by storing the data in column format, which allows us to use some interesting phenomena, like we store similar data together, so we can compress it quite efficiently, but also we can index it and sort it in a way that we are always operating in the millisecond scale. And the millisecond scale is very important to us because it's what gives the real-time aspect in ClickHouse. And we also can adapt the database to any scale. I think the largest clusters we know about are about like 4,000 nodes, but yeah, you can also live happily with a single node. You can submit your queries, get your answers in a set of use cases, usually around real-time analytics, what we refer to as user-facing analytics as well sometimes, because you want to expose these capabilities to your end users. We have also the observability use case, as well as regular data warehousing today. Oh, I just got the results of the poll, and they disappeared from my screen somehow. All right, we have more folks from the Grafana community today, as we expected. So welcome, everyone. I hope you enjoy this content. All right, some of the key features of ClickHouse as a data store are the fact that it is a SQL-based and a SQL-compatible database. So you can submit SQL queries. It's even more than that, actually. It runs and operates an augmented version of ANSI SQL that comes with many table functions, that comes with many capabilities that are tailored for the real-time use case. And this gives it a lot of expressive power to basically ask any questions on top of your data sets, whether it's in the format of a big flat table or with nested elements or semi-structured, doesn't really matter. The table functions complete this set pretty well and gives you a lot of reading power, I guess. It's also optimized to ingest loads and loads of data. Millions of events per second are pretty common, and quite easy to achieve actually out of the box without any tuning. As already talked about the replication in the distribution model, but also the compression that we get by using clever algorithms and locality effects when we store similar data sets together. And then our sweet spot or our strength is all about speed and fast queries. So we have this ability to scan and process very large data set quickly, thanks as well to the secret sauce around the Victoria's engine that allows us to run like sim descriptions and get results even faster. If you use a ClickHouse on a single node, you notice that you use every single core, and that's one of its strengths. Finally, we also have a cloud offering now where we deal with all the scalability and operations aspects for it. So you can check it out if you want to repeat the content of this demo that we'll have today with Dale. All right, I was not sure putting together that slide, but I spent a lot of time playing with my daughter this week, and maybe that's where I got this inspiration. But I see my job as the integrations PM at ClickHouse as basically matching the correct pairs of integrations. And we have many software we interact with. Grafana is certainly on high up in our priority list because it's an interactive UI to dataset that offers analysts, people, developers means to interact with their dataset. So in some sort of fashion, it brings some life to the database and gives you the ability to propose a visual experience on top of it while still getting the power out of it. So for us, it's very important. We invest quite a lot in that, and in the form of proposing this plugin that we will discuss today, but also maintaining it, working in pair with our friends at Grafana to do so. So we decided early on to partner with Grafana. It's been a year or more now, actually, since we started this partnership. It's been quite successful. We are quite aligned on our engineering approaches and vision and requirements. So it's been going quite well, and we're quite happy with the state of this integration. And you'll see it today, I think, live on the screen. You see the decisions we've made designing this plugin. You'll see why we decided to introduce it and why it is the right one to use with ClickHouse. So without further ado, I'll hand it over to Andrew from Grafana to talk us through this journey of like building the plugin.
Yeah, thanks, Riyad. So I'm going to talk about building the ClickHouse plugin, and here are some design decisions worth pointing out. Since we're building a plugin from the ground up, we can follow the latest standards. One standard is making the plugin a Go backend plugin, which gives us alerting and query caching out of the box. We should use SQLDS, which supports SQL database interface and simplifies the backend code. The plugin should also support communication over HTTP and native, and the plugin should also support minimal macros, which may be expanded in the future with time. Generally, we prefer to make syntax improvements within ClickHouse for time series stuff. Next slide, please. So what is the difference from other plugins? Like I said in the last slide, we use the latest frameworks and best practices from the start. The plugin has full type support with ClickHouse, including JSON. This is the first official Grafana SQL plugin to support Adhoc filters. There will be more on this in the next slide. Also, there is the conditional all macro. The conditional all macro you can use it to optimize your query performance when using template variables. And this plugin is also built in partnership with ClickHouse and Grafana, as said before. Next slide, please. So what are ad hoc filters briefly? Ad hoc filters are a key and value pairs that once selected are automatically added to all queries and data sources in a dashboard. You can select the key value pairs in the top left shown in the red box and automatically inject this condition, and it automatically injects this condition into all dashboard panels. The difference from like template variables, which this is relatively similar to, is you do not have to adjust each query in each panel. Next slide, please. So the ClickHouse plugin accomplishes this by appending a ClickHouse setting to the end of the query. You can see that setting appended in bold. It's the settings additional table filter. In this query, we are getting the average commits over time, and we can use the ad hoc filters to get commits only done by Torkel. The additional table filter setting was added to the ClickHouse code base for this plugin. Next slide. So I think I'm going to be handing it over to Dale for a demo. Yeah.
Okay. Thanks, Andrew. Okay, I need to stop sharing. Perfect. Thank you. Okay, let me show my screen. Okay, so we've given you some background on the history and process of building the plugin. Now I'd like to demonstrate some of its capabilities. So for this, we needed a data set. And when I was preparing this webinar, I was curious as to the history of Grafana and ClickHouse ecosystem. And when researching any OSS project, we often turn to GitHub. And one of my personal frustrations with GitHub is their analytics is often a bit limited. So many of you may have seen polls, for example, but it's quite shallow. And it's quite good for a broad overview, but it doesn't really give you kind of the low-level statistics on the repository that maybe as a developer you'd be interested in. So at this point, I wondered maybe we could do something a little bit better. And then I just happened to notice that 10 years to the day was the first commit on the Grafana repo. So happy birthday, Grafana. It was exactly 10 years to the day on the 26th of January. And when noticing this, I thought, well, maybe we can do something a little bit better. So let's analyze the history of the Grafana repository using ClickHouse and Grafana. So maybe we can do something better than this, which is quite limited. But any good demo needs good data. So the first data set that I thought we'd pull in was GitHub events. So we've got all PRs, issues, stars, forks, watches, and comments for every repository on GitHub since the beginning of 2011. So that's a decent size. It's about 5.5 billion rows, which is quite small for ClickHouse, really, but it gives us something decent to work with. That's actually available in our Play environment. So if you go to play.clickhouse.com/play, you can play with that data set. You can also load it into ClickHouse yourself using the details here that I'll link on these slides. So that gives us kind of the broad overview of all the repository. What it doesn't give us of all the repositories on GitHub, what it doesn't give us is the individual commits within the Grafana repo. So for this, we actually distribute a tool with ClickHouse, which is just packaged in. So you can use this tool if you want. It's called Git import tool. You can check out any repository on GitHub, cd into the directory, run git import, ClickHouse git import, and it will generate you 3 files. It will generate you a TSV file with every commit, a file changes file with every file change, a row for every file change, and then at the most detailed level, a row for every single line that's ever been changed in that repository. And I've run this for Linux, and it's, I mean, it's quite a sizable data set for Linux. For Grafana, Grafana is about 1.5 million lines of code. It's still pretty decent, but it's about 10 million rows in total. Okay, so now I'm going to switch to, so to run this demo, we need obviously a Grafana instance and we need a ClickHouse instance. So for my Grafana instance, I'm going to use the free version of Grafana Cloud. You can just sign up to this. It's just straightforward to sign up using a GitHub or Google email address. And the plugin's open source, so it's Apache 2 license. So you can install that and you can reproduce the entirety of this demo just using Grafana Cloud. For the purposes of ClickHouse, I'm going to use ClickHouse Cloud. ClickHouse Cloud is basically a serverless offering of ClickHouse. So you can see I've got a list of services here, and we're going to use this service here, Grafana Webinar. So a service is basically a serverless ClickHouse cluster that separates storage and compute. So we use object store for the storage of the data, and we automatically scale compute with, i.e. memory and CPU, based on your load, and then we scale it up and down as you need. So it's entirely elastic in its scaling. Now, you can reproduce this also on the OSS version of ClickHouse. If you're not familiar with ClickHouse, that's obviously Apache 2 licensed. You could download ClickHouse and you could reproduce this demo as well. And at the end, I'll make sure that there's some links in the slides so people can reproduce this demo if they need to. So in the interest of time, we're going to use the data that's preloaded. I'm going to switch to here our SQL console view. So our SQL console isn't a full-blown visualization tool like Grafana, but it's rather a kind of a query editor with some basic visualization capabilities. So what it does give you is it gives you schema overviews. It allows you to do DDL queries easily. Think of it as more of a scratch pad. I find it much easier to write SQL queries in SQL console and then paste them into Grafana. And also it's got some of these basic visualization capabilities, and it will render visualizations at a very simple layer, similar to the same way as Grafana with regards to the data shape. So if you get the data shape right here, it'll work within Grafana as well. Obviously, if I need full visualizations and workflows, I switch to Grafana. So here you can see my tables on the left. I've got my commits table here. I've got my file changes. This GitHub events table here has got all the rows for on GitHub for all the repositories. So you can see there's quite a lot of information there for every single repo potentially. And at the lowest level, I've got this line changes. And you can see that the line changes for GitHub, this would be probably the first commit way back. The Grafana dashboard, if I sort by time, we can see that this was made in 2013 on the 26th of January. So almost 10 years to the hour, actually, even. Okay. So as an example, I'll just quickly show how I go through the work. I'm not going to do all my queries in here. I'm going to use a lot of copying and pasting for my queries, but I'll just show you the general workflow. So what I could do here is I could, for example, do total commits. That's a very simple one. This data set's about 2 weeks old. I took this snapshot 2 weeks ago, so number of commits has probably increased since this point by maybe 1,000 or so. And then if I wanted to do something a little bit more complicated, I could say group by the total commits, but also group by time and bucket by week. So this is like a group by function for the time. So we get per week. So if I execute this, I get the count, the number of commits per week, basically over time. And I could check this, for example, just to make sure that this is the data that I'm looking for. And we can see how the number of commits has increased over time. Okay, so that's all I'm going to really show here. I might check a few queries, but generally, as I said, is more of a scratch pad for your SQL queries. So switching to Grafana, let's actually start building some proper visualizations. So I have to go to data sources. I have my plugin installed already. If you haven't, you just go to plugins. You can find ClickHouse in this list, and you can install it in Grafana Cloud. It's just a few clicks. I've installed it just in the interest of time. And then the first thing I need to do is just add a data source. So I scroll down, and a data source is basically, for those of you who are not familiar with Grafana, it's just an instantiation of the plugin. So it's a connection to ClickHouse, and we use that data source. And if you had multiple ClickHouse instances, you'd have probably a data source for each of them. So we are going to create our ClickHouse instance. You could see there, actually, I went a little bit quick. You can see it's signed. That means that it's the official plugin. And you can see that we're supporting alerting here. And that's because we use the default, we use the full new framework. So that's free out of the box. So let's just call it ClickHouse Webinar. We need some credentials. I'm just going to copy these in. And port 9440. I'm going to communicate over native. We also support HTTP, as Andrew mentioned. So if you need to switch traffic or introspect traffic, that makes that a little bit easier. The native protocol obviously is a binary protocol. It's a little bit faster, but for this demo, we don't need to introspect traffic. So password, and then just simply save and test. And the data source should say it's working. Great. Okay, so now let's build some visualizations. So I have a finished dashboard, but I'm going to actually go through the process of building 2 or 3 visualizations, and then I'll show you the final dashboard. So new dashboard, and we need to select a panel. I'm going to use the data source that we just created, so this ClickHouse webinar one. And when I select the data source, I'm immediately presented with a query builder. The first thing I'm going to build, I'm going to build a simple stat visualization. It's probably the simplest Grafana visualization. I can just change here, select stat, and I need to start finishing this query builder. So for a stat visualization, for my first statistic, I think I'll just plot the number of commits. So we select the database, and we need to select aggregate here. So we have three options here on the query builder: table, which is obviously more of a listing; aggregate, which is where you need to produce a single statistical value; and then finally time series if you need to plot statistics over time. So I'm going to select aggregate, select my table, which is commits, and then ask for an aggregate of count. And that should be it. So if I run that, I get 35,000. Now, the next thing I probably want to do, other aside from maybe make it a little bit less red, is make this respect the time picker at the top. Now, the time picker here, if I was to change this to last 5 years or last 2 years, let's change it to last 5 years. In fact, let's change it to last 10 years. Fortunately, it actually makes it very simple that we're getting the full data set over the last 10 years. I change this, it obviously is not changing the value. So I need to make the query respect the filter, the time window that's selected in Grafana. And to do that, I'm going to switch to the SQL editor here. And I'm just going to make a small change. So I'm going to copy this in. And you see immediately that I've injected this time filter macro. So what this is effectively doing is it's receiving the time window up here, and it's adjusting this time filter to be like a filter clause. So if I run this, I should still get the same value. Okay, so we're a little bit, maybe we're not getting the lower bound value. But you can see if I click on the debug window, sorry, I'm going to be quick, query inspector here, you'll see that we've actually got a time that's been translated into a time restriction based on epoch seconds. Now, if I was to narrow that by, for example, the last 90 days, I'll get a very different value translated. So that just makes it very, very easy to make sure that the time window is respected. And we'll reuse that macro. That's one of the macros that we provide throughout this presentation. One other small change, I'm going to remove the title up here, such that the statistic just drops in, and I'm going to change this query to commits. Okay. Now I'm going to add a few more queries. I won't go into too much detail as to how these are, and it's fast. I could build these with the query builder. I'm just going to put the SQL straight in these instances. I'm going to compute the number of stars. That seems to be a fair of reasonable interest. What I'm doing here actually is I'm using the full GitHub events data set. You can see I'm restricting to watch events, which are basically stars in that, and I'm restricting to the Grafana repo, and I'm grouping by month, and that's giving me a series of data point values, like a list of data point values, and then this function here is just doing an accumulative sum. So one way of just checking what the data looks like is if we switch to the table view, you can see I've got the commits here. If I select my stars query, you see I've got a list of values. And that's what's being plotted to this line. So it looks like the stars are continuously increasing fairly constantly, fairly linearly for Grafana, which is encouraging. This one is very, very similar, but we're just going to look at PRs. And that's very similar. There's other stats I could do here, but in the interest of time, we'll move on. Okay. So the next thing that if you're using Grafana, you probably want to do time series. And that's what it excels at. So let's build our first time series chart. Let's add a panel. And maybe the obvious thing to do is just plot commits over time. So whereas in SQL console, I wrote the query and I dragged the fields in, let's see if how we would do that in Grafana. Again, I select the data source, except this time I'm going to select time series, and then I can select my database, my table, my time field. And then I need a aggregate, so count, and that should be it. So if I the only thing here is I'm limited to 100 points by default. Let's increase that to a larger value, and we have our commits over time. Okay, there is one other change I would like to do here. So if you notice here that the query has actually we've automatically produced this time filter. So if we take a look at this in SQL editor, you'll see that we've got this time interval filter here, which is what I described before. So as I select this window, this filter will drag, which is what I want. But notice also we've got this time interval macro that's been automatically added. What this is doing is it's taking the time window and it's grouping the data points by an interval that's appropriate for that window. So if it's 10 years, it's appropriate to group by a day. If you're looking at a small window, like, I don't know, 10 minutes, it's more appropriate to group by second. And as I drill down, that means that ensures that that bucketing is adapted. If I try to plot millisecond points over 10 years, the graph will be slow, but also probably unreadable. And if you look here, you can see we use this toStart of interval function. And for this time range, I'm using 8,600, 400, which is basically a day. If I drill lower, you'll see that that value changes to something, probably that's half a day. Okay, and let's go back to 10 years. Okay, so I'm actually going to always bucket by a week for this chart, I think it's and to do that, I need just to make that week, and that week. Okay, so that just visualizes a little bit better. Okay, so we can see how commits have changed over the weeks since Grafana was created. So next, the final visualization I'm going to build is I'm going to build a multi-series line chart. So the obvious thing that probably people, the next stage of the chart here would maybe be top authors over time. So who's making the most commits on the Grafana repo over time. So again, I'm going to add a chart, select my data source, and I'm going to use the query builder again. So select time series, select my database, select commits, select time, select my aggregate, and then just add a group by. Done. So maybe we change this to 1,000 and we run this query. Now, Grafana has automatically recognized that this is effectively a multi-series line chart. So it's built that for us already, but you can see there's some fairly obvious problems here. The main problem being that we are plotting every author over time. So the limit is applied on the data points, not on the authors. What we really want is to take the top 10 authors and plot their activity over time. So for that, this is where I would go to the SQL editor. Now, what I'll point out is once we go to the SQL editor, we can't always go back to the query builder. So you'll notice here, it'll say this is maybe too complex to populate the query builder. And we do that for a good reason. If I put a more complicated query in here with many joins and CTEs, etc., then it's quite possible that we couldn't render that in the query builder. So we just warn you that maybe that isn't possible. In this case, it would have actually been successful. So my query here, this is actually my query that I'm going to use. Sorry, wrong query. This is the query I'm going to use. All I'm using is a subquery, so I'm getting the top 10 authors over time, and then I'm doing exactly the same query, but I'm restricting the authors to that top 10. And if I run that, then we get something a little bit more interesting. So you can see the early commits by Rashid, and then Torkel was obviously for a long time the only committer, and then we start to get a flurry of activity, and more recently it's pretty much everybody. It's lots and lots of committers, which is encouraging. Okay, I'm not going to develop that anymore. I do have maybe one more visualization if we have time. I think I can squeeze it in before I show you the main dashboard. And this is really for those of you that are on the call that are contributing to Grafana, so or that watch this video. So I was curious, and I did this one because we did this here for the ClickHouse code base, and the developers were interested to see who's deleting each other's code. And this actually visualizes quite nicely. I'll do it very quickly, and I won't use the query builder. You can, but in this instance, it's a little bit quicker just to drop the query in. What we're effectively doing is just saying, looking at a single line of code and saying who added that, and then who made the next change to it, and then pairing those authors together to give us pairs. If I run this query, you'll see that I've got add authors, delete authors, and counts. Now, this is a kind of perfect visualization to visualizing a Sankey graph. Unfortunately, that's not functioning in 9.1. So kind of went for the next best option, which is TreeMap. This is actually a community plugin. It's quite easy to style. I'll just do some quick styling on this. group by delete author, and then maybe we'll turn off the color, and we'll go, let's say yellow, green, red. So we can see that Bergquist has Torkel has deleted most of Bergquist code, but obviously in the opposite direction, and there's some interesting parents between Magnus and Eric. So this is quite interesting. If you're familiar with the code base and you work on the code base, you can see who's responsible for deleting most of your code, which is, as a developer, is always interesting to see who's editing my code. So that's just an example. Let's go to the actual, before I go to the full dashboard, I just want to show you macros and variables and ad hoc filters. So variables allow you to basically create a custom control element. So in this instance, it's a drop down of values, and you can control the query which populates those values. And then when you select a value, you can have that value injected into a query to act as a filter. So I've said a lot there. So let's actually see what that looks like. If I go to the dashboard settings and I go to variables, I can click add variable. And if we go down, we select query, and I need to select my data source. And I'm going to allow us to filter by author. So I'm giving my variable an author name. I give it an author label. So this is how the filter will be displayed. And then I need a query to populate the values. And I'm just going to get all of the distinct authors from the commits table. And that should give me all of these authors. And finally, I'm going to allow a multi-value, and I'm going to allow an all option as well. So if I save that and I go back to the dashboard, you'll see I now have an author field. Now, obviously, if I select this, it's not going to apply to any of these dashboards. So to do that, I actually need to go and modify the query. And this really highlights the weaknesses of variables. They're great in the sense they're very targeted, but you actually need to go and modify them in all of the SQL, all of your statements. So I modified the SQL statement for here to say, make sure that if there's an author selected here, if I select Rashid, you'll see the selected author, or the author value, has to be in this list of authors. So if I look at this and I run this query, you'll see that what's effectively become is author in Rashid. Now, we've also got this conditional all macro wrapping around this use of this variable. And that really is an optimization. So if I didn't have that and I selected the all, what it would inject in here is a list of all of the values, all of the authors, which would produce this huge maybe of 10,000 values. That would be quite slow. With that conditional all, it recognizes that the all's been selected, and it just translates that to a 1 = 1, which will be optimized away by ClickHouse. So that makes it just run a lot faster. Obviously, if I come up here and I maybe select Torkel, the downside of this is that now it's only going to select his commits. So how do I get around that? Well, the next piece of functionality and the main reason we wanted to add this was because of this limitation, which is ad hoc filters that Andrew talked about. And this is quite powerful, and it's much, much easier to add. We just simply go to variables, we select a new variable, and we select ad hoc filters. And then we just select the data source. Okay. Now, what this will do is it will present us with a three-part selector. You'll first select the column, then the operator, and then the value, and it will populate the list of values based on the column that you select. And it will list all the columns by default in the entire service of ClickHouse, or the entire cluster. Now, that is obviously, I'm going to actually give this a name as well, so it doesn't just appear so just as the default query 0. Or if we want to restrict this by a specific table, for example, and only list the columns for a table or a database, we can do that. There's this we just have to add a constant variable which won't be shown, and we give it the name ClickHouse_ad-hoc query, and then in the actual value we just put the name of our database. We can also do the name of a table, so we could do default.commits, for example, and then we could also even comma separate different tables and databases. I'm not going to in this instance. I'm just going to say only use the columns in the default database. And this is actually important because if we don't do that, we actually get columns from the underlying system tables and all sorts of things that we're not really that interested in. Okay, so you see we now got this filter, and I can actually now just select any column. So I can just say authors equal to, let's say Rashid, and you'll notice that all my visualizations get filtered. They don't down here. Why do stars and PRs not get filtered? Because these are using a different table. And here I'm selecting the commits.authors column, or the authors column on the commits table. I would actually have to go and add all of the other, I'd have to go and add the equivalent for this GitHub events data set, which is, I think the field's called something else. I think it's called owner or committer or contributor. So that's all I wanted to show with respect to actually building visualizations. Just to wrap up, I'd like to show the final dashboard that I did build. And maybe a few insights for those of you that are familiar with the code base. So we have obviously see stars, PRs, issues, commits over time. Here we've built a moving average. One of the things that I initially thought was, well, the number of commits is actually fairly variable, but what about actually the amount of code that's changing? And you can see here that although the number of commits isn't maybe increasing, the actual amount of code that's being made, the number of line changes that are occurring is really going up. So probably average number of lines per commit is increasing. We can see we've got fairly linear growth of project size to 1.5 million lines of Go and TypeScript code now. The top committers over time renders better as a heat map. I did it as a line chart before. You can see that Torkel's still contributing to this day. I imagine his role has changed somewhat, so that's quite admirable that he's still able to get code and contribute, find the time to contribute code. We talked about who rewrites code, hottest commits. If you're interested in what the hottest commit is, this is fairly subjective, I should say. It's based on comments and authors. But when Grafana first added a Docker file, there's a lot of people with an opinion, so I'm sure we would expect that. Files which have the most authors, so settings.go, fairly logical. If you add a feature to Grafana, you've got to go and change the settings.go file and add a setting. Files with the longest history, so some obvious ones here, package.json pretty early on, and we can see the introduction of Go in 2014, and I know Kibana continued with a JavaScript backend. And maybe that was a good decision to move the back end to Go. Sticky code, whose code actually sticks around? Well, obviously Bergquist and Torkel, I think, were very early on at Grafana. Torkel, obviously the founder, their code's still sticking around, but some shout out to Andre, who seems to write code which sticks around for on average quite a long time. Files which by average age, so obviously grunt packaging files, a code which will exist for quite a long time and is probably not going to change. Most popular issues, I was interested to find out what this one was, and just by authors and commits, the most popular issue ever was way back in 2015 when Grafana decided to add an alerting system. So that's by comments and by the number of people that contributed to that issue. So we also decided to look across all the repository data and see what was the activity with respect to repositories containing ClickHouse and Grafana. So is the ecosystem, collaborative ecosystem increasing? And it is, and you can see even here our plugin at the end as we released last year. So we're now starting to consume a reasonable amount of activity with this plugin. This is interesting. I thought I'd curious to see who commits. If you commit to the Grafana repository, what other repositories do those people commit to? And they generally raise issues and they watch things like Terraform, Prometheus. Obviously, they're close to the committers' hearts. And then just on the final ones, a shout out to the people that contribute to both repositories. So Dan and Felix from Grafana, and also Simpod from Grafana has made some commits to ClickHouse. So thank you. And then just on a final note, I looked at what is the total, who starred, how many people have starred both repositories, but more importantly, which repository do they star first? So that makes sense. Most people seem to star Grafana first, and then they discover ClickHouse, and that would align with the answer to the poll at the start. So thanks, and I think we're back to Riyadh. Thank you, Riyadh.
Thank you, Dale. We're slightly over time, so we'll have to quite quickly on the next session. So let me share my screen and talk about the lessons learned.
Yeah, I can briefly talk about the lessons learned. So we identified a couple lessons learned. Well, the first one is avoid tying your success to a unified component. So Grafana is building a generic SQL visual query builder, and we wanted to use this, but it is currently not suitable for our needs. So we had to make our own solution in the meantime. The next lesson that we learned, or I learned, is a very painful lesson I learned, which is avoid trying to build a abstract syntax tree or AST unless you're looking for a challenge. But the most painful part of this lesson was I had to tell Dale that he did tell me so. So yeah, and then early on, or so more context on this, early on, we wanted to use an AST for the Adhoc filter and the conditional all macro. The idea was we could parse the query and inject the where clauses in the appropriate place. But after several bug reports and drastically increasing complexity, we decided to retire. It was best to retire this. And we pushed a lot of this to the ClickHouse side, which definitely knows how to use or create its own ASTs better than TypeScript. So yeah, next slide.
All right, so next I have a few words on the roadmap, and we just also triggered a poll here to get your opinion. So we have big plans for this plugin since we know that people are getting a lot of value out of it, and we want to make sure that we orient our investments toward things that people are expecting. So we are thinking of introducing the new unified SQL query builder that Grafana introduced. We are also thinking of a better support for the histogram we have in the Explore view. At the moment, it's computed client side. We can do better. We want to introduce a live tailing of documents in the Explore view, support for streaming queries, and potentially introduce PromQL support in ClickHouse. So these are things that are just ideas at the moment. They're getting some traction already. We are socializing this, but feel free to vote and share your opinion of what you think we should do next, and we'll be happy to prioritize the roadmap regarding that. So with that, I think that's the end of today's content we've prepared. We still have some time for Q&A, but before we jump in here, we listed some interesting resources. So if you want to build the same demo that Dale did, you can do it real quick with almost zero setup. Just open a ClickHouse Cloud free trial, a Grafana Cloud free trial, and you can start it in seconds. And both Grafana and ClickHouse are doing a good job at putting content out there for people to consume. So feel free to do so, and you'll find us on every social platform, obviously. Let me read the questions we have. I saw some questions popping in. All right, one question is about what are the steps to ingest the data in real time to reflect the charts? Dale, maybe?
So we do this in the play environment, actually. I'll put a link in the chat. Effectively, what we do for commits is we just run for the commit data. We every night we repull the repo, we rerun the ClickHouse Git import tool to regenerate the 3 files. We create a table which is like slightly different, the name of the table, like version 2, insert all the data, and then we just switch the tables over, and we basically do an exchange of the tables. That ensures now the commits data, because ClickHouse is so fast, you can push up 10 million rows. It takes a few seconds. It's not fast. Doesn't take very long at all. For the GitHub events data, that's a little bit more complicated. It is documented in our docs how to pull the GitHub events data, but it's quite sizable. But I think you can pull down either daily or weekly. I think it's daily files. So it's just a question of pulling the files down by the day, where they generate a dump basically every day. You pull that down, convert it, and it's just append. It is immutable, so there's no changes or updates in the data, so that makes it a lot easier. But yeah, you can just get a daily feed of that data in effect.
Thanks, Dale. And the next question is about the side-by-side comparison between ClickHouse, Druid, and Pinot here. don't think we publish anything in that front, but we do maintain a benchmark actually called ClickBench. I don't know, Dale, if you can paste a link to ClickBench into the chat. It's an open benchmark that anyone can contribute to, and I believe these systems are part of it. And it's a very open approach from ClickHouse here. Anyone can contribute to this. So if you have a system that you think can perform on that benchmark, please feel free to test it and submit a PR on that repository. We'll be happy to publish it. And we believe that's how systems get better. And finally, I think we'll take one last question. Is it only incremental data that's getting pulled from GitHub events, i.e. CDC?
Yeah, so the GitHub data doesn't get changed. Right? There's nothing in GitHub which really requires a change capture, because it's just append only. Like people modify comments, but it gets issued as another comment with the same I think a different doc with a different row. But generally, yeah, it's just append only data. So it's quite trivial to handle. And they publish those as separate files. I can put in the docs as to how to actually download. Let me just grab the link as to how to actually download and work with that data. I think, if one moment, GitHub events, here you go. It's in our guide. You follow the link that's in that page, and you'll see it actually said 3 billion records. It's now about 5.5 to 6 billion records. And the download size is now about 100 gigs, so it's quite moderate.
And I don't want to put you on the hook, Dale, but I guess we will publish also the dashboards you built, right, for this one. So that's also a way to explore the same data set.
I will. And in fact, maybe I should do that right now. Let me just generate a snapshot of that dashboard, which expires never. If I publish that, I'll put that in chat as well, so people can go and look at that dashboard. And I think you'll be able to. I'm not quite sure the drill down capabilities that Grafana provides, but there's the link to the actual snapshot dashboard. But I'll look to see if we can do a read-only instance as well for people to go and play with.
Great. And yeah, I think with that, we covered all the questions we have. Big thanks to everyone who was involved in preparing this content, but also to the attendees. Feel free to continue this discussion in our social channels. We will share an email, I think, at the end of it with the content you just seen, and maybe we'll include some extras in there. Thank you very much, everyone, and have a great day ahead.